Okay, PARCA Clinical Section 4.5 covers quality assurance, quality control, reject analysis, test plates, and bantoms. Quality assurance. Quality control and assurance are critical in an imaging department to make sure that the appropriate technique is used for optimal image quality while trading off potential harm to the patient. Some of the radiology terms which are used for QA/QC applications are absorption, attenuation, penetration, scatter, contrast, and density. QA is an ongoing process to improve quality through careful examination of ongoing activities. So that's an important one. It shows up on test questions. QA is ongoing. You're always doing QA. The QA monitor plays an important part in this analysis. So during the first shift, the 7 to 3 or the 8 to 4:30, whatever first shift is in a particular hospital, there is a human who performs the role of QA monitor, and they spot check the image quality before it gets sent to the radiologist. And if you have a study and you're like, oh, I don't know, this is kind of borderline, I don't know if I should put this through or not, or if I should redo it, you can go to the QA monitor and say, hey, QA monitor, what do you think? You think that this is good enough, or do we need to redo it? QA procedure involves collection of data according to monitored activity, making a plan based on gathered data, and finally implementing the procedure to meet customer needs. Pay attention to that sentence. It also shows up in the test questions. Quality control. Some of the radiology terms which are used for QA/QC applications are absorption, attenuation, penetration, scatter, contrast, and density. The key parameters to make the image appear the way it does depend upon differential absorption, thickness of tissue, and radiographic techniques. So differential absorption, contrast. Is it a black next to a white, or you have two shades of gray? Thickness of tissue. Hands are thinner than the thigh, so you got to use different radiographic techniques. We talked in an earlier module about KVP, and so there's some other settings you can put on the X-ray machine, but that's what a radiographic technique is. So QC is an active, ongoing process which measures the image quality based on the QA plan and takes corrective action if it does not meet the requirements. So here are those terms they're talking about. Absorption, X-ray absorption or attenuation, allows us to use X-rays to produce images. The dark and light areas on a radiographic image represent the intensity of X-rays that reach the detector plate. So where the X-rays went right through will be dark. Where the X-rays didn't go through at all, it will be light. So that's absorption. Attenuation means the exact same thing as absorption, and this is where it gets tricky. Anytime you see absorption and attenuation as answers on a test, the answer is always absorption. So if they write a question that says, what causes the dark and light areas on a radiographic image? Answer A is absorption, answer B is attenuation, answer C is penetration, answer D is scatter. You always choose absorption. I know that sounds weird, but this is what we've learned from previous students taking the PARCA exam. Attenuation means the same thing as absorption, but absorption is apparently always the right answer. Penetration. Penetration is the degree to which X-rays have passed through the body, so that's how hard or soft, how strong or weak the beam is. Scatter is radiation that spreads out in different directions from a radiation beam when the beam interacts with the substance, usually the patient body tissue. Contrast is the density difference between neighboring regions on a radiograph. Do you have a black next to a white, or do you have two shades of gray, or a black next to a gray? And density is the overall amount, degree of darkening on a radiograph. Is it completely white? Is it completely black? That's the difference in density. Reject analysis. The use of repeat reject is an important administrative tool which is usually performed by the QA/QC technologist to track the number of repeated rejected images and the reason. So if you are a technologist and you are constantly rejecting your images on the QC monitor, right, you're constantly taking bad images, you have to reject them and go do them again, they keep track of that, and they, if you're constantly retaking images, you're exposing the patients to more radiation, and you'll have to do some sort of retraining, and they will try to get you up to speed, and if you can't and you constantly take bad images, you will get fired. So reject analysis, that's what that's about, and it's done by that QA monitor or QA/QC technologist. Same person, different title. Test plates and bantoms. To ensure the proper operation of any process, standard measures are used, such as maintaining proper checks for image quality as part of the radiology workflow and regularly using a QC test pattern or actual radiation test phantom. So QC test pattern, hopefully y'all remember when we did that and we went over the SMPTE test pattern and all those different AGP test patterns, or you can use an actual test phantom. One of the ones that PARCA loves to talk about is the step wedge. And so down here we have a step wedge. It's just a piece of lead that's made like stair steps. And so at the biggest step is 9 millimeters in thickness. This is 1 millimeter in thickness, and it produces an image that looks like this. And you can see you've got black on this end, white on this end, and all these shades of gray from the different level of steps. And so that's a good way to tell if your machine has been properly calibrated by using a step wedge. And that is all about section 4.5. Thank you for watching.